Hello everybody, my name is Emanuele Ragnoli. I am a mathematician and cryptographer by training, and I am the CTO of Provably, a startup that was funded circa 1 year and a half ago, and that is building a verifiable database infrastructure for verifiable data collaborations. I like starting seminars by telling stories, because a product is a technology, and the technology is a story. This story starts in 2006 in the corridors of Hewlett-Packard in Palo Alto. Some HP scientists, notoriously Haber et al., decided to answer the question how to verify outsourced data and computation, including the verification of both correctness and completeness of relational database queries, such as select, project, and union. We give protocols for privacy-preserving verification of aggregate queries, including sum, max, mean, count, average, and median. The story continues with a blog, a database analysis blog about Apache Iceberg and Snowflake. The blogger states, storage is like a bookshelf filled with books. The books are of little value, other than the core, until they are read. The same applies to data. The high value is computer analysis. The next turn of the story touches the concept of books and shadow libraries. Why do we care so much about papers and books? Let's set aside our fundamental belief in preservation in general. So, why papers and books specifically? The answer is simple: information density. A library is not a mere collection of books, containers of data. A library is a mean to store and diffuse information. And the last turn of this story, I promised the last turn, is from 1992. Jim Carville shaped the Bill Clinton presidential campaign with a simple message: it's the economy, stupid. In the last few years, the trends describing what was happening around the data sphere have been simplified with messages like data is the new oil, or data is valuable, but if unrefined, it cannot really be used, or if data is the new oil, algorithms are the new refineries. What is that story telling us? It talks about a trend of data, information, and what I call the information sphere. I think the new trend can be simply captured with it's the data stupid. The need of collaborative computing, a concept in which actors get to compute algorithms, train models, derive insights from data sources, are pushing for the adoption of secure, robust, and mature implementation of advanced cryptography, database technologies, and distributed databases. Analytics and their compute is being moved away from storage, distributed among distributed data sources, to account for economy and data distribution. On the other hand, in the realm of Web3, more and more requirements of coupling open public data, like the transactional ones in blockchain, are being coupled with personal private data from other non-Web3 systems to drive smart contracts to take advantage of informational inside that are not stored on the various ledgers, being those L1 or L2s. It's the data stupid that describes a world where human and machine agents, think LLMs, are more and more hungry for data to train, search, discover. And the data are not coming anymore in the shape of a huge open world wide web that was easily discoverable first by spiders and then by semantic searches. Searching and extracting information must deal more and more with data that are in a fragmented, ownership-driven set of sources. Data remain private because the risk of opening and sharing them does not match the potential incentives of automated collaborative computing. Instead, workflows and standards prefer to adopt IT policies that are coupled with strong legal contracts for data collaboration and sharing. Alice masks part of her data to allow Bob to access them and derive queries, with Alice and Bob protected by legal contracts. A product is a technology is a story, and some stories have a happy ending. So, what could be the happy ending of this story? The happy ending is an electric vehicle that is coupled with AI agents, creating a smarter car capable of negotiating charging and exchanges of electricity, power, and data with other cars. The happy ending is a blockchain that, coupled with off-chain personal data, can authorize personalized lending with proper compliance. The happy ending is AI agents that can train on proprietary data and verify that the training has been done completely and correctly. Our society collects books and it distributes them among official and shadow libraries to create and preserve information density. We have not reached the point to do that with data and the insight generated from those. There is no information density that comes with data because data and information are either isolated or unreachable, or data are scraped by algorithms that remain proprietary to the firms that apply them. But we are not there yet. I like continuing seminars by telling stories. A product is a technology, and a technology is a story. And any story has villains and challenges. Because to have an happy ending, we need to solve four challenges. We need to stop revealing the data when it is private, or we need to stop harvesting it without permission. We needed to make privacy easy because unfortunately advanced cryptographic techniques like zero-knowledge proofs, full homomorphic encryption, and multi-party computation are complex and sometimes hardly scalable. We need to have privacy for big data because some of those advanced cryptographic techniques are unfortunately too slow for the big data themselves. And we need to solve the issue of trust and verifiability because the data ecosystem needs verifiability of data and verifiability of analytics. There is no collaborative computing if we don't create automated processes that substitute clunky and costly human interventions. And automation only comes with advanced but user-friendly technical tools that guarantee provenance and prove that the analytics were computed correctly without necessarily sharing the data. Developers face significant challenges regarding data integrity and verification, as there is no single tool for the remote data verification. This lack of data integrity tools is identified as an OWASP top 10 issue. It has existed for a few years. The consequences are substantial. Developers spend considerable time and money addressing fraud and broken systems. They urgently need better tools to verify data integrity. Given that billions of API data exchanges occur daily, the absence of robust data integrity measures incurs significant costs. The rise of LLMs and the agentic web is expected to multiply this volume, leading to a projected increase in data spoofing and fraud. Currently, there is no adequate tool for proving solvency and custody in the crypto banking and centralized exchange sector. A significant problem arises in providing verifiable proof of solvency without compromising sensitive data and financial data. Crypto banks and SECs aim to demonstrate their solvency to both customers and regulators, but existing methods often require leaking sensitive information such as user data, fiat account details, and crypto custody information. This highlights a critical need for a solution that can query financial data and generate insights with proof, while ensuring the privacy of user information for regulators and users. A compliant crypto network operator wants to offer condition-based DeFi lending. The user aims to receive a personalized interest rate based on conditions like driving safely and saving a certain amount monthly. This requires integrating various data sources such as health data, mobility data, and banking data with DeFi smart contracts. Currently, there is no tool that acts as a private data oracle to verify such conditions and enable compliant DeFi lending. Current technologies have limitation in verifying data correctness. Public infrastructure can prove data sources, but not its correctness. Verifiable credentials prove issuer claims, but are limited to identity. Blockchains ensure data integrity and produce simple proofs. However, they cannot perform complex operations like proof of reserves. This means existing tech struggles to verify if data is authentic, mathematically correct, or complete. I like continuing seminar by telling stories. A product is a technology, and the technology is a story. To have an happy ending, any story needs heroes. Otherwise, who solves the challenges? At Probably, we have built a product with three core capabilities. First, it offers verifiable data inquiries, proving the correctness and completeness of how, when, and where data was processed. It ensures cryptographic integrity across the data lifecycle and queries, including data provenance and verifiable SQL on big data. Second, it's a verifiable database infrastructure, VDBI, for existing databases, deployable in minutes without migration. Third, it provides trustless collaboration, focusing on security, privacy, and integrity. Probably ensures integrity throughout the data journey. This includes verifiable reporting and analytics, producing auditable data for compliance. It eliminates manual audits and legal contracts by enabling probable reports. Probably also facilitates trustless collaboration, unlocking remote partner data for smarter outcomes. Finally, it provides verifiable APIs and AI answers, offering a cybersecurity tool for reliable AI responses on private data. In one of the case studies that we are working with a major AI API security partner, uh, we focus on API responses. As we said before, classical PKI ensures that the data was untampered with, but not the correctness. Probably ensures that the data is authentic, correct, and complete. It also verifies that the data originates from the system of record. Probably builds a distributed chain of trust. It allows for fast local verification without repeatedly querying the source. This protects against attacker injecting spoofed data. In this fintech example, probably verifies the data is about the right customer, the credit score was computed correctly, and with all the relevant complete data. In this other case study that we are working with a fintech partner, we demonstrate how verifiability transforms compliance and auditing. It enables faster, cheaper, and more effective auditing processes. Probably facilitates real-time verifiable and probable analytics and reporting. It also allows for verifiable data collaboration with regulators and partners. This is achieved through a global independent verifier network. In this other case study, we work with a major automotive industrial partner, and we examine how federated verifiable data and AI networks for automotive can work. It involves searching and collaborating on federated verifiable data. This includes an EVM data network with a client reference across over 100 countries. It supports millions of users, partners, and assets. The network enables trustless collaboration with end-to-end verifiability. Data remains local, private, and compliant. This unlocks insight for EV data monetization and energy trading. It also enables agentic collaboration and verifiable payments with various partners. You will see more details of these in the demo in the last part of the seminar. In the roadmap that we have adopted, we have released up to now 4 versions of the product. We have released the first 2 versions with the cryptographic protocol that is built by composing Pedersen commitments, bulletproof, and Merkle trees. And the second, latest 2 version, with a protocol that is made by composing vector commitments and set accumulators. What are Pedersen commitments? Pedersen commitment is a way to lock in a number so that no one can see it, but you can later prove you committed to that value. Call those range proofs. It's like a locked box that hides a number and no one can open it unless you show the key. Bulletproof is a way to prove something about a secret number without revealing it. These are type of range proofs. You can think it like a magician proving they know the number in the box is less than 100 without opening the box. Merkle trees, at the same time, are a way to store lots of data and later prove that some pieces of it is correct very efficiently. It's like a super efficient filing cabinet where you can prove a specific page exists without showing the whole cabinet. Vector commitments are a way to prove that you know that certain values are in a list or a set, often used in databases, authentication, or blockchains. You commit to a list of values, like an array, and later you can prove what's at the specific index without revealing the rest. Consider it, for example, like a sealed envelope with a row of numbers. You can prove what's at slot number 3 without opening the whole thing. Set accumulators is a way to compress a set of values into one small digest and prove whether something is in the set or not. It's like a single receipt for a shopping list, and later you can prove you bought a milk without showing the whole list. Why this evolution? Because we wanted more SQL queries, more databases. We wanted more scalability, and we wanted to account for complex big data. We wanted to reach the sizes of deployed databases that go in the hundreds of millions of rows with milliseconds for querying and receiving results for those queries. We achieved that by May 2025 by gaining 100x bigger data with continued speed improvements. Cryptography has been at the center of every major tech shift. In the 2000, it was TLS for the web era. In the 2010, it was secure enclaves for the mobile era. In 2020, our thesis is that it will be verifiable data infrastructure for the AI era. Now I leave you with a demo of the automotive use case that we have developed with a major automotive industrial partner. Thank you.
Hi, I'm going to quickly show you how to log in as an admin into Provably and show you how easy the tool is to use to create and share verifiable data. There's only two main sections. On the left here is the data that I am bringing to the network. I have a middleware, which in this case I'm running as a SaaS solution, and this middleware is connecting to these databases, and those databases have some tables and some columns in there. So I have the schema and the tables. It's super easy to bring this in. I just press the plus button, and I'm currently using this SaaS-based middleware solution. Soon you'll be able to run your own local middleware, and all you have to do is provide the database credentials, and that's it. Once you've done that, it will appear on this list, and you'll have tables that you can then use to create what we call collections. Collections is, think about it as a data catalog that you're saying, you're curating the data that you want to make available to your partners. In this case, I've, for example, created EV sales data. And in the sales data, what someone else can see when they log in as well, when you invite them, is that they can see the columns, they can see the descriptions, column type, but they can never actually see the actual data. And I can also go in and change the status from public to private. Private may mean it's only available for certain people in certain networks, or listed, which is that someone must ask you permission before they actually run any queries on it, or it's draft, which means it's not shared at all. Now, I can also invite users individually, or I can run queries straight away. I can run some SQL queries. So let me run a SQL query on someone else's data. In this case, I'm going to choose EV financials, and I will run some data on, let's say, the bank loans one. And I'd like to see the total amount of funds, so total amount of loans made by the bank to its customers. So I'm doing select sum amount public loans, and it tells me that just over $1 billion of loans have been made by the bank, and it's going to generate a proof. And the proof in this case, I think it took about 10 or 12 seconds, and it ran that on a pretty large data set. I think in this case we had like 2,000 rows, and I have a proof which I can very quickly verify, and now I can understand that this remote system, it tells the answer from this remote system is correct and complete, and I've also verified it. And you can run different types of queries like sum, count, min, max, and there's more and more of these coming. Pretty much you can run general purpose SQL queries depending on the permissions of the data owner. Another thing here is you also have API keys, so you can bring in different applications to run SQL queries on this data. And we also have here a little chat assistant that helps us to find the best answer. So I can, for example, say I want to ask some questions on this, and I can ask a question like, how many customers does the EV Financials have? And it should give me a natural language answer with a proof that, so it's telling me that there are 10,000 customers in the EV Financials, and it's just generating a proof to confirm that this is a indeed a correct and complete answer. And I can of course verify that. And I'm just going to show you another question. So that's verified, and I can rely on that. I can also run what is the total loans in dollars made by the EV Financials, and it's basically a llama model doing natural language to SQL, finding the best possible answer in your growing list of data collections. And you can make this as sophisticated as you want. You don't have to use our assistant. You just use the API and build your own based on the descriptions, and then you can get better and better, more accurate, reliable, verifiable answers. Thanks. That's pretty much all the. This is everything.